we're going to talk about how to make a histogram, which is the next type of graphical representation of quantitative variables. So what I would do is I would pause the video just for a moment and read this page. I'm not going to insult you by reading this to you. Just go ahead and read everything that's on here. Just pause it and work through this. So we have to make the histogram. Now this is something you guys will be able to do with technology as well, but it's good to be able to make it kind of by hand too, at least once. So we're going to take the data from the beats per minute that we took with the class, and we're going to go, all right, those run from 60 to 90. So 60, counting by fives makes sense. There's not a right or wrong answer necessarily. There are some answers that will be very bad, some answers that are definitely just fine. But counting by fives is a good way to go, I think, with this data. That's the width of each bar. The class interval or the bin should be 5. So for this particular example, 5 is not a bad way to go. It's not the only way to go, but I think that'd be a pretty easy way to go here with the data that we have. So you just the other thing you have to do is communicate which end of each bin goes with which. All right, so for each interval, there's a variety, it's not really a formal way of communicating this necessarily. I guess we'll look at the book, we do together how the book does it. But I'm going to say that I want to use the left endpoints of each bin as being included. So if somebody has a 60, it's going to be in this first. It's going to be in this first one. All right. Okay. If somebody has 65, it's going to be in the second one. So I'm going to include the left endpoint, but not the right. Okay. Something like that. You need to include that information, and in the book, there's examples of what you do. But let's actually do the counting now. All right, so from 60 to 65, there's, how many? I lost it. Dang it. 1, 2, 3, 4, 4. This is also not set in stone, like how big to make the scale. So there's the first bin. Everything from 60 to 65, but not including 65. Right, so 60 to 64, so these all would be whole numbers. Okay. Then we go from 65 to 69, right? Because the left endpoint is not included. So even though this says 70 right here, that's not going to be in the next one. That's from 65, which is right there, to 69, really. So 65 to 69, what do we got? 1, 2, 3, 4, 4. So another 4. That's easy to draw. Boom. Same height. Okay. It's good to label. You should label the axes. So this is beats per minute, part beats per minute. And this is, the y-axis is frequency. And I don't have a ton of space, so I'll just say it. The title of the histogram could be heart rate of the AP Statistics students. All right, so from 70 to 74, to the next bin, there's 1. Double check. Oh, I screwed up. There's a 68. There you go. So you can see it's easy to mess up, and I just messed up. So let's back it up. 68. So between 65 and 69, there's 1, 2, 3, 4, 5. Oops. So I hope nobody freaked out when I did that because I'm not going to redo the video. But it's all right to see a mistake here and there. It's not the end of the world. So there's 5 in that then. So from 70 to 74, how many are there? So there's 71, 73, 72, 70. All right, so that was 1, 2, 3, 4, 5. Another 5. Okay, from 75 to 79. Actually, I'm going to stop. I'm going to pause it. I'm going to finish it. And it might be a good idea for you guys to look at the notes. I'm going to just pause the video, and on the smartboard, I'll finish it so we can talk about it a little bit. Because I don't want to take up the video forever here. I don't want to take up your time or anything. So I'm going to pause it, and then I'm going to finish the histogram. So there you go. There's the distribution. I only screwed up a couple of times with the bins where the left endpoints are included. So this bin here on the, let me point to it like you guys can see on the video. This bin here has 60 included, but 65 not included. All right. The green bin that I'm coloring in right now would have 65 included, up to 69, and so on and so forth. That's what this business is trying to communicate there. So there's a histogram. You can analyze this histogram just like you can do, you can analyze the distribution of this variable with the histogram just like you can with any of the other graphical displays we looked at, dot plot, stem and leaf, etc. Okay. The last thing I want to talk about, really I should have talked about before, is what an outlier is. There's a technical definition. All right. But right now, all you need to know, we won't talk about that till later. Right now, you need to know is it's a number in the data. So it's a value of the variable that one of the individuals takes on that is very far from all the other variable values. In this case, this is a histogram of the salaries of 1984 University of North Carolina graduates. That graduating class included Michael Jordan. So his first salary, as one might expect, was significantly far away from everybody else's. And what I just circled in green is the outlier. Okay, and that is an important concept because outliers can dramatically affect certain statistics. They might be indicative of something important within the data, and so it's good to know what an outlier is. So that's the last thing that I want to point out. All right, so there you go.